Welcome to this station, Integers. And at this station, we're going to learn a little bit about zero pairs. Here's an example of a zero pair. Nope. Here's the example of the zero pair. Here's an example of a zero pair. And so what we want to do is we're going to create some of these two-sided chips. They do not need to be in circles. This is, these are actually purchased through some of the different vendors that we have. So you can actually buy these. If you do decide to buy them after you make these and you really want to have bigger sets, then I would recommend buying the set that are the foam ones because they're less likely to be tossed across the room. Sometimes that happens. But if you have students that are chewers, these are not yours. So you might want to mix it up. There are some plastic ones available. So let's get started. Remember, in this station, you're going to be taking the foam and you're going to be gluing it together using the pre-sticky back. And then all you're going to do is once you get them together, you can then just cut them into squares, rectangles, up to you how you want to use them. I like squares just because then they can kind of be used as algebra tile constants for later on if you decide that you want to use those as well. You can also make the algebra tiles out of the two-sided foam as well. So here we go. Let's now move to a little bit about the subtracting and adding integers using them. So once you get these made, how can you use them in your classroom? So here's the question. If yellow is considered a positive 1 and red is considered a negative 1, we know that if you combine those, a positive and a negative, they cancel each other out. So let's look at this problem. What is the total here? What is the total here? Let me move myself down, shrink myself on the screen. So if you notice, you have zero pairs. So you have a positive and a negative, a positive and a negative, and a positive negative 1. So technically this is positive 3 added to negative 3, which equals 0. So that's how the zero pairs work. Seems simple, but this is what we want to do is we want to see how it works in operations, and that gets a little more complex. So I'm going to do some demo here on the screen, and you'll have this video for later use. So let's take a few minutes to show some examples of how to use this. Here we have a problem on the very first one, and I'm just going to highlight it here. Positive 5 added to positive 2. Well, the red is the negative 1 and the yellow is the positive. So I could then say, here's what it's going to look like. 1, 2, and then we add 2 more positives. And so very simple, easy to do, okay? Now, we could count up and then we would find our answer 7. Some students get confused with negatives. You throw a negative in and then they forget about all the rules. So we want to help students just conceptually understand this, reduce that stress, create a positive environment. We have these scaffolds now to help students, and all of a sudden they have this visual support. -4 plus another -1, and then how many do you have altogether? All of a sudden it seems that it makes more common sense. So here we have a problem where we have positive 6 in yellow and we have -3. This is the power of the zero pair. We didn't really see it in the first two problems, but here we see it because we now can connect a positive with a negative, positive with a negative. And if we take those and we remove them, we take these and we drag them away, then what we have is just our positive 3 left. And so conceptually, students can understand that, they can see it, reduces their stress, and it creates that visual support that students need to recall information and for it to make sense. So they'll remember, oh, okay, a positive and a negative joined together. So that's the power of the zero pair. Let's see it again in another problem. So here's another problem, -3 added to positive 2. Again, students can visually see, using these supports here, that we have created zero pairs and they cancel each other out. And so if we actually grab those four again and we take them away, then students can see that the sum of -3 and +2 is -1. So that's adding. What about when we subtract? This is when we start pulling these banks of zero pairs in to help the problem make sense. So let's start down here. We're going to have a simple problem again. If students see this, 5 subtract 2. Well, that seems to be easy. So here we have our +5. We're just going to grab these +2. We're going to remove them. And now we have our answer, +3. Simple. Let's look at the next example. So here we have -4, and we want to subtract a -1. We have a -1 to be able to pull away, so we're going to just move it out of the way, and our final answer is -3. All of this makes sense. This is where we get a little bit crazy on this next problem, because the next problem actually is 6 subtract -3. And students are going to say, well, I don't have -3. And so let's see how this plays out. Pretty cool. So here we have our +6. 1, 2, 3, 4, 5, 6. We need to subtract -3. We do not have -3. And here's the power of the zero pair. We basically will take and we'll add enough zero pairs until we have the correct amount, until we have the -3 that we need. So I've added 1 zero pair, 2 zero pair, 3 zero pairs. Now, if I wanted to do this problem, I can continue on and I can just simply remove these -3s. 1, 2, 3. And now students can see if I have a problem that is subtraction, this is why we have the answer being larger than what we initially started with. So the answer is +9. We'll do one last one. So here we start with -3, and we need to subtract a +2. Well, we don't have +2 to subtract, so ask yourself, what would you do next? You would add those zero pairs, just enough. We don't need to add more, just enough to actually have the amount that we need to subtract. So I'm adding in our zero pairs here. We'll put them up here. And now I can remove the +2. Simply just grabbing these +2, dragging them away. And here we have -3 subtract +2 gives us -5. That's the power of zero pairs. And I have to say, I find that once students have this knowledge, then it makes sense. They can have a visual support in their mind through this use of manipulatives to support their understanding of simple addition and subtraction with integers. So now your job is to take the sticky paper that is on the table next to you and the scissors and just make your own sets of zero pairs. Two-sided makes them more versatile than if they're just one-sided. If you decide later on you need addition and you don't have two-sided, then yes, you can just have a yellow chip and a red chip. I would stick with yellow and red just because that it is helpful when we start using algebra tiles. So thanks again, and I hope you enjoyed this station.